I'm just going to say a few words then. Yeah, a bit of a call for help and general introduction. Thanks everyone for joining us this evening, and a massive thanks to Zoe and Jonathan for coming on board and sharing tonight. Yeah, like I say, a few words, a bit of background. For those of you that don't know me, my name's Barry Cranford. I'm the founder of the London Java community. I'm not a developer myself. I run a tech recruitment company called RecWorks. So at RecWorks, we've been on a mission for about the last 12 years to prove that recruitment can be a force for good in the tech industry, beyond just getting people jobs. And that's often around learning, mentoring, career development, that kind of thing. To put simply, if people want to learn something and other people are happy to share, then we're happy to put that together in the middle there. And that can be on a group basis, like this evening, or on a one-to-one level. So the biggest example of what we do is the Meet a Mentor community, which has got really close links to the LJC. So we've got about 1,700 members in there, and we've made 2,500 personal introductions. But we're always looking for more mentors. So there's loads of things we do in there around aspiring speakers, aspiring CTOs, and all sorts, helping everyone from students all the way up. So if anybody's happy to help out, mentor a few extra people, or can do anything to help, then please do come and talk to me afterwards, or look me up on LinkedIn. We'd love to hear from you. It's all powered by revenue from recruitment. So if you're looking to hire any point in the future, then please do bear us in mind. Anyway, on to tonight. I'm actually going to hand over to Zoe Laycock in a second, who's going to be the co-host for the remainder of the evening. But before I do, just a reminder that Zoe and Jonathan have kindly donated an annual subscription to the O'Reilly Online Learning Program, which is worth $500. So that's going to be selected and given away at the end of their presentation. So this is an annual subscription. It gives you access to all that the online platform has got to offer. So if you're looking to get certified, this means that you have access to all the learning and practice materials that you'll need to pass the exam. So like I say, Zoe's going to announce the winners at the end of the event. And Zoe, I'll pass back over to you now to yeah, say a few words about yourself and Jonathan.
Thank you. Thanks very much, Barry. So hi, everyone. And Jonathan will introduce himself in a moment. My name is Zoe Laycock, and I am the head of product marketing at Undo. And Undo, for those of you that don't know, is a leader in software failure replay. And essentially, what does that mean? That means that we specialize in helping making developers' lives easier by actually providing a product called LiveRecorder, which is a record and replay debugger. And essentially, you know, we're on a mission to help everybody who is in the application development space to make better applications, push through the throughput of delivery, and really just try and help you guys to actually spend more time building rather than debugging. I am a former developer, started my development career out in Seattle, and somewhere along the line took a wrong turn and moved over to the dark side, which is product marketing. I do like it because it helps me to keep close to the technology, and I don't really know anything about marketing, but I'm very interested in driving up usage and product experience and developer experience. So I'll pass over to Jonathan, who is going to be speaking to you today. And just before I do, I just want to let you know that we really welcome interaction in this session. So if you have any comments, please just make us aware of them, and we will try and stop and pause to try and answer any questions that you have. Over to you, Jonathan.
Hi, I'm Jonathan Harris. I'm VP of Product, and I'm particularly concerned at the moment with our LiveRecorder for Java product, which I'll be demoing later today, which is just coming to market. Our background as a company is in kind of C, C+, and assembler. So Java is a little bit of a departure for us. Today I want to talk about software failure replay, and because no one knows what that is, I'm going to talk about what problems trying to solve, what vendors exist in the space, and then give a live demo of our particular solution. So let me figure out how to share screen on Zoom. Can you guys see that okay, Zoe?
Yeah, I can see it.
Great, thank you.
Yes, I can. Sorry, you just said that as I went on mute.
Of course. So pretty much what I said, I'll explain what problem software failure replay is trying to solve. And then I'll talk about what software failure replay is, how it works, various vendors and the differences in technical approaches that they take, and then demo. And let's hope the demo gods are with me. So, reproducibility. Diagnosing software defects is hard, and it starts being hard with just getting a defect to even reproduce. So quite often you might find, and I guess I'm hoping or expecting that this is your experience too, but you'll find that like it maybe works on your machine, but then when you deploy into a staging or pre-prod environment, suddenly it fails, and you're kind of going, okay, so what's different? Maybe it's something different in the environment, the data that's being processed, or perhaps your application works fine in the staging environment, but then fails in production. Maybe it fails only intermittently, or maybe you've got a kind of flaky test, or actually a sporadic failure in production. Or another scenario, sometimes you're maybe running a SOAK or a stress test, and maybe your software only fails after a few hours of runtime. These are all reproducibility problems. And sometimes it feels like this guy here, kind of like, you know, maybe it depends on the phase of the moon or something. You know, it can be really quite difficult to even reproduce a problem. And to put some numbers behind that, we did a survey with the Register and Freeform Dynamics, and survey says 50% of engineers' time is spent diagnosing and fixing software defects. And I think that's kind of in line with other surveys and other studies. So that's an awful lot of time. And 91% of software engineers have unresolved defects because they can't even reproduce them. Reproducibility is a problem because if you think about those 91% of software engineers, those unresolved defects, it's basically you've got a decision like, do you just ship anyway and hope that your customers aren't really going to be too like affected, or do you hold up release while you spend some more time trying to reproduce the problem? So reproducibility is kind of problem one. Problem two is debugging is actually a kind of weirdly, deeply counterintuitive thing to do. So a lot of people debug just by sort of poring over logs, but if you're a bit more sophisticated, as I'm sure most of you are, then you'll fire up an IDE or some kind of debugger. And your experience is probably a lot like this guy, where you kind of step through, you're trying to kind of find out where's it starting to go wrong. And then you go, oh, and you just blow past it, and then you have to start again. And this is like sophisticated debugging, right? This isn't looking over logs. This is somebody who's using an IDE, but it's counterintuitive because like you'd quite like to start at the end and work back rather than start at the beginning and work forward. So pretty much as soon as people invented the idea of an interactive debugger, back then, I guess this would be C or assembler, back in the kind of end 60s, beginning of the 70s, there are some academic papers about the idea of being able to debug in reverse. But academic papers, but no practical solutions. And then pretty much nothing happened for 30 years until GDB, native debugger on Linux and other Unix environments, added some support for reversible debugging back in 2009. It's kind of more sort of proof of concept. It's not really usable for real work. Last time I tried it, it ran thousands of times slower than natively than not under debugging. So that was interesting, but really not much help. So these are the two problems that are really quite difficult to solve. Firstly, reproducing a problem in the first place, and then quickly getting to the point where the failure actually occurs in your code. I said nothing happened for 30 years, but in the last few years, things have started to happen. And various vendors have entered into produce the thing that we call software failure replay. The idea of software failure replay is that you can record the execution of your application software in test or in prod or in pre-prod. You save a recording if it fails, and then you reversibly replay the recording to diagnose the failure on your developer environment. That's the basic idea. Implementing this relies on two basic insights. One is that programs are mostly deterministic, apart from when they're not. So that is, if you have a bit of Java code and you kind of enter into the start of the function, say, and run to the end, it'll pretty much always behave exactly the same way. Your variables and kind of stack and heap will always end up in the same state at the end of that if you just run the program again and again, provided that the inputs are the same. So programs are mostly deterministic, apart from where they're not, and where they're not is input. So input from file system, input from the network, maybe thread scheduling within the Java VM. These things are non-deterministic inputs. So you can replay by rerunning the same code that you ran at record time and reinserting these non-deterministic inputs. You don't have to record every bytecode that's executed, every instruction that's executed. So you can rerun the program and reinsert exactly the same inputs at exactly the right time in order to make a program replayable. So that's insight one. By the way, as Zoe pointed out, do stop and ask questions if anything's not clear. Insight two, so that was how to replay a program. To be able to reversibly replay, well, computers don't go in reverse, right? But we can fake it. So in order to reversibly replay, what we can do is jump back to a previous point in the execution of a program and run forwards. So as shown on this diagram, going backwards, we can achieve by jumping to a previous point in time, previous snapshot of the program, and running forwards to the previous instruction or the previous line of code. So in this way, if we combine these two things, we can replay a program's execution and we can reversibly replay program's execution. So in the last few years, a number of software vendors have started to offer software failure replay solutions. In alphabetical order, Microsoft, a couple of years ago, like in beginning of 2018, came up with time travel debugging. They've been working on it for about a decade, but launched it with Windows, WinDebug in Windows 10. This operates on .NET and C++ code on Windows. The way it works, obviously I'm not from Microsoft, so this is an outsider's view, but this is kind of my best understanding, is essentially virtualization. It's running the program in a virtualized environment, and as the program executes, it's kind of taking notes of what the program's doing. So it's a virtualization, even though as a user, it doesn't appear like virtualization, but that's actually what's going on under the hood. Coming out of the Mozilla project, there's RR, and there's a commercial spin-off by Robert Callahan called Panosco. This is C++ on Linux only, and its implementation relies on hardware performance counters. And what it's doing is using hardware performance counters to measure exactly when various inputs need to be fed into a program at replay time. So at record time, it's using hardware performance counters to notice when certain events happen and measure exactly when they happen down to kind of CPU instruction level granularity. And at replay time, it's using hardware performance counters to spot when the program's got to that time and therefore then insert that non-deterministic input. Another approach is taken by Rev Debug. This is .NET on Windows. only, and they take a very different approach. Both Microsoft and Mozilla are doing kind of stuff at runtime. Rev Debug is actually annotating at compile time. So it's a kind of slightly different version of the JDK, and it's putting in, or sorry, not JDK, of the .NET compiler, and it's putting in enough instrumentation into the program so that it can, at replay time, insert, again, non-deterministic inputs at the right time. And the company I'm from, Undo, we have a product called LiveRecorder. This is C, C++, Go, and Java on Linux only. And we use a kind of blend of approaches, partly in-process virtualization, similar to Microsoft, but also some just-in-time instrumentation of the code that's executing. And we're operating at the level of x86 or ARM assembler, not at Java bytecode level. But we're noticing at kind of x86 level, various non-deterministic inputs again, and at replay time, we're using our instrumentation to reinsert the non-deterministic inputs that have been saved. So there's kind of similarities of approaches, but they're actually all sort of using these two basic insights as far as I can tell. One is you don't have to just kind of record everything that a program does, you just record the inputs. And the other one is to reversibly replay. You just go back to a previous moment in time and run forwards rather than actually going backwards, because you can't go backwards. There's also one thing that I've not listed because I don't know too much about it, which is Chronon, which is Java on Windows and Linux. And I think they use a instrumentation approach again, but with different trade-offs. But I'm not that familiar with it, so I haven't put it on this slide. Okay, so that was all pretty quick. Let's go and see what this actually looks like in practice. If you'll give me a second while I switch screens. Okay, this hopefully is a Jenkins pipeline. Did that come up okay? Can't actually see what I'm sharing, see what I mean?
It's all good.
I'll assume it is. Okay, so this is Jenkins. I presume you're kind of at least vaguely familiar with Jenkins. If it looks weird to you, it's because it's the Blue Ocean UI, which looks nicer, so it's great for demoing. It's actually pretty kind of not as functional as the traditional UI. But anyway, this is really simple, but kind of basic application release pipeline. So we're doing some checkouts here, we're doing a build, we're running some system integration tests, and then we're pushing to release, and we're done. Except we're not pushing to release because tests are failing. This pipeline's got this extra step here, where when tests fail, they're rerun under recording. So at the test stage, we've got 2 passes. I'm using Avocado here as my test runner, but it doesn't really matter, and 4 failures. And so at record, in the next stage, those 4 failures, I'm rerunning the tests and running them under recording. So 4 runs, the 2 that passed, this pipeline set up to skip. And what that actually looks like, and I don't know if you can see this, is we've inserted agent on the Java command line, which is our recording tech. And the way it's set up is it's always recording. So each test as it runs is recorded, and a recording is saved out. Because this is Jenkins, recording is saved out as Jenkins artifacts. So for the 4 failing tests, as well as a bunch of logs that you conventionally get out of your failing tests, we've got 4 recordings. Oops, 4 recordings, 1 for each of the failed tests. And I'll look at, in a moment, we'll look at what it looks like to replay them. But before I do, let's look at another use case. So you remember I was talking about the problem of reproducibility. So some of our customers in C, C++ world have big problems with reproducibility. And one of them in particular has set up a Jenkins pipeline that they call their sporadics farm, for farming sporadic failures. And so that's the name I've used for this thing. And the idea here is you've got a failure that happens maybe like after kind of multiple hours of running, or maybe it only fails 1 in 10 or 1 in 100 times. Doesn't matter. This pipeline is set up to keep rerunning that test and keep rerunning it under LiveRecorder recording. When it does fail, then we stop the pipeline and save out one of those recordings as, again, Jenkins artifact. And what this pipeline's done, in effect, it's taken a flaky or sporadic or fragile test and turned it into a 100% reproducible use case. Because these recordings contain the 1 time in 10 or 1 time in 100 that the thing actually failed. And when I replay these recordings, it will always fail in exactly the same way. So this is kind of why it's called sporadics farm. It's for farming those sporadics. Okay, so that's how you generate a recording in a test environment. In a production environment, I'm not going to show you, but you can kind of understand the principle works in a similar way. We insert a Java agent onto the Java command line, and that allows you to either record the entire execution or record programmatically under the control of your application. Your application can decide whether to record itself or not. So that's what recording looks like. Let's go to replay. So this is IntelliJ running on
Jonathan.
macOS.
Hey, just want to stop you just one moment, because we have a question which is coming from Lakshmi, who says, can I install the recorder in Jenkins as a plugin?
Kind of looked at that, and I'm not sure whether that's the right approach. Maybe it is, maybe it's not. The way it's set up at the moment here, if I go back to how it's set up here is actually as a changing the Jenkins kind of test runner. So it doesn't really work as a plugin. I mean, I guess it could be made to. We haven't done it here, but I guess, you know, sorry, I'm kind of thinking as I'm talking. Yeah, probably could. That's not what we've done here, but it's probably worth looking into.
Yeah, sounds like an idea. And we have a second question, which is, why do you need the Java agent if the instrumentation is at the x86 level? That's a good one.
Basically, because an agent is agents are fired up before your application. The way that the JVM works is it'll like call into the agent before it starts your application, and we just need a way of getting in early into the thing. So this is how we're basically inserting ourselves into the thing. So what the agent's actually doing is spawning off another process which reattaches to the JVM and does all that x86 instrumentation stuff. So it's just a hook, basically. Seemed like a kind of convenient way of integrating.
That sounds great. Thanks for that question, Ron. And we don't have any more, so let's resume, but keep the questions coming and we'll answer them as best we can. Thank you.
Cool. Right, so that was record. This is replay. So IntelliJ IDEA running on macOS in this case, because that's what I'm using. It kind of looks pretty conventional debugging session that I'm in the middle of here. Couple of differences. One is this isn't actually debugging program live. What I'm doing is debugging a recording that came out of that one of those Jenkins pipelines when it ran, I think, like a couple of days ago. So what I'm taking is one of the intermittent failures, and here it's at the end of the recording. There's this timeline along the top, and as you can see, we're near the end of the recording because we're about to crash out. And every time I run this recording in the debugger, it'll behave exactly the same way because it's a recording, it's not live. The other difference is, because it's a recording, there are some extra buttons here. So here are the normal IntelliJ step buttons, etc. We've got some extra buttons here for going backwards. So if I hit one of those, and I hope the connection hasn't timed out while I've been talking, you can see that we go back in time. So if If you remember that guy frantically like hitting his debug step over button and missing the event, well, now we actually have a let's go back in time button. So that's kind of cool and stuff, but let's see how we can actually use this to diagnose a real problem. So this particular test program has crashed out with a concurrent modification exception, and it's about to crash out of that with an uncaught exception. Concurrent modification exception, I guess, I mean, like we're all Java guys here, so I guess you guys know this, but in case anybody doesn't, there's kind of two versions of it. There's the stupid version, which is where I'm iterating through some list or array or kind of other iterable, and while I'm iterating, I add or delete or somehow modify the iterable while I'm iterating through it. And usually that's a kind of dull moment, and you fix it, and all is well. The other kind, though, and that's the kind we're looking at here, is where you're happily iterating through an iterable, and suddenly it goes bang, and you know it's nothing you've done. You've just happily iterating through. Some other thread has come in and manipulated the iterable that you were iterating through behind your back. And the problem with that is you only discover it after the fact. So like I've just got this really simple loop here, and the loop's blown up, and it's nothing I've done. So this is actually a real difficult one to diagnose because it's some other thread coming in, and it's a timing issue. You know, it's come in at the wrong moment while I happen to be iterating through this thing, and it's me that blows up. And this is quite difficult to diagnose, but we're going to diagnose it anyway. So first thing I'll do is let's go and have a look at that exception. So this was a concurrent. This is the standard IntelliJ breakpoint dialog. So I've set a breakpoint on concurrent modification exception, and then I can use this extra button here, which is to run backwards. So let's do that. And so I'll run backwards, and I've gone back in time. I don't know if you noticed this little kind of time indicator moved a few pixels. And this is where the exception is being generated. It's being generated within ArrayList class, virtual class, because some internal counters not what it was expecting. I can go a little further back in time if I go and look at the implementation of that counter. I can put a watch point on that, and then I can run further back in time to see who's manipulating that internal counter. So if I do that, I'll run a little further back in time, and now I'm in, well, this mutator thread. I don't remember that. Let's just step up, and here we are. So this is obviously a trivial example, but here you can see the other thread coming in. It's not guarded in any way, and it's just interfered with the list I was iterating through and caused me to blow up. The interesting thing is this mutator thread isn't even running at the point where you catch the exception. It's kind of been created and disappeared. So if I, let's see, turn off that exception and maybe just run forwards again. So let's go forward in time. Here we are about to crash out again. If I look at the threads that are running, there is no mutator thread. So this thread has been created, come in, interfered with me, and gone away. And you can imagine how difficult that kind of issue might be to diagnose if you didn't have the ability to actually just navigate back and forwards through a recording as I have just done. So, summarize, that is what software failure replay is. This is what I've been showing you is Undo's version of LiveRecorder on Java. There are other implementations available for Windows and other languages. But this is our version, and I hope at the end of this you get a feel for what software failure replay is and how it can be used to diagnose kind of either everyday defects in your application delivery pipeline, or, as I've shown you, actually potentially quite difficult defects too. Okie dokie, that's pretty much all I have to say. Any questions?
I have a question, if you'll take it.
Yeah, go ahead.
How do you deal? So you ran the unit test, which had a thread in it, and then you ran the replay that replicated the same state.
Yeah.
But how did you ever So those threads are running independently. So surely there's timing issues.
Yeah, there are timing issues.
How would the recording between how are you guaranteeing like the sequential consistency between the different threads?
In this implementation, we're doing a lot of serialization. So we have to spot when the JVM makes a thread switch, context switch, or asks the kernel to. We have to spot that, and we use a lot of serialization to guarantee, which has a performance impact.
Oh, and so is that the agent implementation that's doing that? Like, how are you serializing all the interactions between threads?
We are lying to the kernel about how many CPUs are available.
Oh, so you're doing like you're basically doing a pinning of all the threads into a single core, so you can effectively.
Yeah, kind of. Yeah.
Okay.
And obviously, we need to know when thread switches happen, because at replay time we need to make the threads switch at exactly the same moment.
Okay, but in the sample you gave us, you showed us the test ran first without the agent or stuff running. Yeah. Was there something already running in that test that meant that you could reproduce the same thing when you actually, because you attached the agent in your second run to collect the data, but it still had the same bug as the first one. But if it's a concurrency bug, then it's not guaranteed to occur the second time. How is that?
Yeah, so this kind of pipeline I'm looking at here really only works for things that reproduce pretty reliably. So this pipeline is assuming it's a kind of routine logic failure, and therefore it will reproduce. This second pipeline is set up for that kind of sporadic case where you'd have to kind of run it quite a few times. So it's the nature of a sporadic or flaky failure that it won't always fail in exactly the same way, or it won't even fail at all, like some runs. So the idea here is, at least if you can get it failing and record that, then you can diagnose.
Okay. And sorry, just a follow-up question, if it's all right.
Yeah.
What information, out of curiosity, like are you actually recording? Are you recording the entire like memory state? Are you recording like any changing of variables? You know, what is the actual recording?
So this is a pre-release version, so I've got this extra cunning window which actually shows what's going on under the hood. And what's going on is we're actually recording at the x86 level. We're recording things like system calls to the kernel that the JVM makes. When the JVM makes a system call, say like it's a read from a socket or something, when the kernel returns, it returns with some data, and we kind of intercept that and stash that data away. So at replay time, we can insert that data, and the call to the kernel doesn't actually happen. So that's probably the bulk in terms of amount of data in a recording. It's actually returning data that's being returned by the kernel because of file I/O or network I/O. But we're also recording things like, there's an x86 instruction, for instance, that tells you time of day. So when that happens, we stash away the time of day, so that at replay time, the program thinks it's the same time of day as it was at record time. And that might be important because, you know, maybe the program only fails on a Wednesday.
That's pretty interesting. So you actually get replay on external stuff like such as time that you can get from the kernel. Okay. So does that, like the recording, is it pretty large? Like how large does it get over the course of like time? Like, you know.
Yeah. So these like are toy examples. So they are in the order of 50 meg, which is, you know, nothing. It really depends. Like, I'm going to sound a bit weaselly, but it really depends how I/O heavy you are, or actually in practice how I heavy you are. So we have to record all the input, we'll compress it and stuff. But so if you're having like megabytes of input a second, then we'll be generating megabytes of recording a second. But generally we sort of hand wave about 1 meg a second. But it really does depend how heavy you are.
Thanks. Nice talk.
Anything else?
Do you have any other questions?
Yeah, if I can ask, you mentioned that you lie to the program and say that you have only one CPU core.
Mm-hmm.
Does that mean, I'm not saying it's bad, I'm just asking, does that mean that you can't spot memory visibility issues that have to do with fences?
Actually, we can, but there are at least in theory some kind of concurrency issues that we can't get. Our customers tend to find that concurrency issues occur in general, perhaps with varying, sometimes they find they occur more under recording and sometimes less frequently under recording than they do kind of native without recording. Ultimately, it kind of doesn't matter because as long as you can actually get it to occur under recording, then you can diagnose. But the short answer to your question is, yeah, there are in theory some memory fence errors that we can't detect.
Thank you.
We do have a technology under development for to fix that, but it's a way out. And we have another technology under development which we call thread fuzzing that we have in our C++ and Go products, but don't yet have in Java, where we actually manipulate thread scheduling, because we have to basically know all about thread scheduling. We actually have the ability to notice when something like a fence is called or a lock and mess with thread scheduling at that point. So schedule a thread immediately after the lock is called or immediately before, and just mess with thread scheduling to try and provoke those kind of subtle concurrency errors to occur more frequently than they would otherwise. We call it thread fuzzing because it's kind of a fuzzing technique, I guess.
Do we have any more questions?
I just had one question. Sorry, I might have missed it because I joined slightly late. But I just wanted to ask, how do I try my hands on it? Can I download a free version or something to just test it?
Zoe?
So LiveRecorder for Java will be launching shortly. It's essentially an enterprise product, and so comes with a certain price tag. And the reason for that is, although we're Linux-based, basically it's a platform and a solution that's worth deploying for mission-critical applications. So in sectors we find that our key industries are data management, database, banking, telecoms, EDA. We have a beta program that is pretty much the answer to the question, which is for those of you where you see some value in what we've worked through. We have a beta program that will actually be open until the end of the year. You can go to undo.io. And in our blog session, you can find a connection, a link through to LiveRecorder for beta, or you can just Google LiveRecorder for beta, or you're welcome to get in touch with me or Jonathan, either on LinkedIn or directly. The organisers of the LJC can put you in touch, and if email's your preferred channel, we're happy to steer you towards the beta program as well. I think at this point, that's probably the best way for you, not only to get your hands on and play with the product, and we can start with just giving you a quick run through, but also there is also the it also gives you the opportunity to be part of our product design process, which is driven by end users, by developers such as yourself, and really we are looking to build the best product we can. We would not say that we're there on day one, and we would really value any input from the community in evaluating, testing, playing with the product, and feeding back about basically what's needed next, you know, how best to fit this into your workflows with existing tooling, build tools, CI tools, and stuff like that. So for anyone that gets in touch, this is probably the best way to play with the product at this point.
Thank you.
I'll reiterate
You're very
Zoe's point that we are really interested in getting feedback. So if you're at all interested in playing, then please do get in touch.
Okay, so if we really appreciate you guys actually joining us, and we appreciate the opportunity to tell you about software failure replay, but also to get your feedback. Do we have any further questions before I go on to, yes, we do. In fact, we have a couple of questions, so I'm going to read them out. We've got one from Craig McDonald. It says, Golang seems an odd choice to support if you're targeting enterprise. What's the reasoning behind that? It's a good question, Craig.
Twofold, really.
Yeah.
Actually, no, threefold. So Go is actually used like for realsies. There are people deploying actual serious applications on Go who aren't just Google. So, but I understand the tenor, which is it's not really enterprisey, but it is a real language, real environment. Short answer is because we could. We have for C++, and the work we had to do for Go was not so great. And secondly, because we knew we wanted to do LiveRecorder for Java. And back when we made that choice, we had pretty much zero cloud experience. So Go was a good way of segueing ourselves into cloud and cloud native. That's the real answer. We're not actually making serious sales in Go. Probably for the reasons you identified, because it's not particularly enterprisey.
Hopefully that answers the question, Craig. We also have one from Dale Waterford. Dale says, do you use this in production to record, say, the last 10 minutes rolling and feedback errors, or is it mainly used for pre-production testing? We've got a second question there. Also, if you have a third-party calls in integration, can you re-record the same thing running locally with third-party access?
Right, two very different questions. So in production use case, we have customers for our C++ product who absolutely use us in production. What can I talk about? Okay, so for instance, in the EDA industry, if you're a company like so kind of phone manufacturer making chips, then you'll use software from companies like Cadence or Mentor Graphics, and that ships with a version of LiveRecorder. So exactly, it's set up so it's not always recording, but it can be, the application can turn on recording, save a recording, and then that recording can be diagnosed out of in a less, in an easier to access environment. For our Java product, we're just bringing it to market. We're focusing on development use case, but it can be used in production in exactly the same way. There is a speed overhead or slowdown, which means that kind of varies, but it might be anywhere between like 2 to 5 times slowdown, depends on use case. So in production, you wouldn't really want to be running it under recording all the time and just save the last 10 minutes. It's more, okay, it's falling over in production, our customer's pissed off. Let's turn on recording and get it to fail, and then turn off recording and go back to full speed. So it's not yet at a level of performance where you'd want to be running all the time, but it is used in production for when you know you've got a failure.
And I think what we find is that in the production, arguably the production use case is arguably where there is highest sort of value if one was to place a monetary value on what our tool can enable and how it can help technical teams. It's kind of a bit of a strange way to look at it, but essentially when your software is failing in production, the cost to a business of its services falling over can be huge. Cost in monetary terms, cost in terms of lost revenue, cost in terms of all of us developers will know that when just as you need chance to actually investigate with a calm head and try and get to the root cause of a problem, that's exactly when usually you'll get non-technical people screaming down over your shoulder saying, when is this going to be fixed, and not giving you any time to work. And so in terms of accelerating mean time to resolution, but actually crucially reducing and minimizing the amount of downtime, yes, there is an overhead, but actually it's at those times when trying to deploy the quickest method of bug detection and resolution really comes into its own. That said, we actually find that most of our customers tend to see the clearer use case in both development, build, and also in tests and QA. So we stepped through, sort of CI examples today, which is more about integration system testing prior to deployment. But also we're seeing, greater amounts of interest in shifting testing left earlier in the software development lifecycle, but also interest in just enabling sort of cross-team collaboration and constantly trying to improve workflows. And so rather than handing off in the past, perhaps a test QA team would hand off a test report, using LiveRecorder, you can take a recording of the failure and actually append that with, priority bugs that need to be fixed. And so you can actually pass that to a developer, and rather than them getting a report about a failure, you can actually pass something that is actionable, something they can work with, and moreover, you debug the recording. So in terms of workflow, it's a little bit smoother.
Yeah, just to build on that, somebody in Microsoft told me that with their time travel debugging, they use it internally, and they say to their testers, don't give me a bug report, give me a recording. Because bug reports you have to think about, recordings you can just replay. There was a second question, which I'm not sure I fully understood, but I'll try and answer anyway. And
do you want me to recap it? Or?
No, it's
okay.
a problem of my understanding, I think, rather than memory. If I haven't answered it, then tell me what I'm getting wrong. So the question was around third-party code. So the nature of recording is, in order to be able to replay faithfully later on, we have to record everything. So we don't really care whether the code is actually Java or JNI'd into some C++ or even assembler. We have to record it faithfully anyway. We don't also care at record time whether you've got source code or not. Typically, at record time, you probably don't have source code available in your, certainly not in your staging or prod environments. So we record just like the execution of the JVM and therefore your application, whether it's calling third-party code or JNI, it doesn't matter. And at replay time, we replay, obviously for your benefit, it's easier if you've got source code. If you don't have source code, then the IDE will do its best to basically reverse compile the bytecode, as it's doing here for the Java system libraries, actually, I think. Or maybe no, this is actually source code. Anyway, if you've got source code, the IDE will show it. If you don't have source code, then you'll get a worse view. But ultimately, it doesn't really matter whether it's your code or third-party code. We'll record it at record time and we'll replay it faithfully at replay time. irrespective of whether you've got the source code available or not. Does that actually answer the question, or did I get it wrong?
I think so. Dale, do you feel that answers what you're getting at? A second to come off mute. Hopefully that answers the question. We have a couple more. We have Suleiman, who is asking, we sometimes deal with bugs that are related to external services that are developed and maintained by other teams in a large project.
Yeah.
We don't understand until we fully debug our part, and it takes a lot of time. Does this product make it easier to identify these kinds of issues?
Yeah, so there's kind of two approaches. One is you just record and replay your application, and you can kind of see the input coming from that other service or server or whatever that other team is owning, and you can kind of diagnose. So usually that might be enough. You know, you can go take that to the other team and go, you know, why are you sending me this thing? Sometimes it's not, and the interplay is more complex. And what you might want to do is actually record both your service or application and their service and look at the interaction between them. So they're quite often interesting bugs are nobody's actually doing anything overtly wrong. You're not getting any errors, but the actual output is wrong. And quite often that can help if you can replay the two recordings in lockstep, and kind of you notice that one of them, the service is sending you something, and you look at it, and so you can replay that, and then you can also replay you receiving that in your application, and you can step through and kind of there's a conversation going on, and you can have recordings of both and replay both. And that can be useful for these more subtle defects where it's not just somebody returning you an error code, it's actually sort of a more complicated underlying problem.
That sounds good. Dale came back and confirmed, yes, you did answer the question. Just throwing this out to everyone else. Does anyone else have any further questions at this time? And again, just to reiterate, Jonathan and I can be found in various parts, lurking around various parts of the interwebs. So we welcome questions at any time on Twitter, LinkedIn, or some other way. But do we have anything else now, or shall I wrap the session? Okay, I just want to, and it's fine if further questions come in, but I just wanted to thank everybody for attending. We really appreciate the opportunity to tell you about software failure replay and LiveRecorder. Hope the session was both informative about advancing techniques and methods for debugging and prior to detecting errors in your applications. We think that it's a method that's quite relevant not only to issue resolution, but also, like we said, to improving processes between people and general developer DevOps objectives. At the beginning, I think Barry mentioned that we were giving away a prize, and that's, I don't know if you're like me, but when I go to developer conferences, I really enjoy the swag. Well, we couldn't bring you swag today because we're on a virtual line, but what we wanted to do is find something that was useful and hopefully will make whoever the lucky recipient is happy. So of all the people on the line now, it's our pleasure to announce that we do have a lucky winner for our prize draw. This has been taken by attendees, so you all had a chance, but our lucky winner happens to be one of our questioners, Dale Waterworth. So congratulations, Dale. Thank you very much for some useful and insightful questions, and you are the lucky winner of a year's subscription to O'Reilly Online Learning. and we have your details. We'll be setting that up for you tomorrow, but we have your email, so I will make contact with you tonight, but we will sync with you tomorrow to get that all set up for you. Dale looks very happy in the chat. I hope that it's useful for you over the next 12 months. And I'd like to say again, thank you to everybody for tuning in. Both Jonathan and myself are usually probably more comfortable being participants, silent participants at the London Java community, but we both tune in on a regular basis to the other presentations and talks and lightning talks that others give. I personally find it hugely useful. I like being part of a community. It's been a real lifesaver as we've all been in lockdown. And thank you very, very much for allowing us to be part of the community. So I think we don't have any further questions, so we will, it's the top of the hour almost, we'll give you two minutes back. And thanks for tuning in. In the chat though, I will just say there is, for anyone that wants to see this demo again, there is a link to an on-demand version of this demo of LiveRecorder for Java. And yeah, hopefully we look forward to seeing you all again soon. Thank you.